Okay, we're going to solve this problem. The problem says a machinist drills circular hole in a panel with a nominal radius r is equal to 5 millimeters. The actual radius of the hole is in the range of r equal to 5 millimeters plus r equal to 5 plus or less, more or less 0.01 millimeters. So the first question is, to what number of significant digits can you express the radius? So we have to take into account the tolerance of the hole, which is plus or less 0.01 millimeters. So the values that the values that the radius of the hole could get is between 4.99 to 5.01. We're going to call this R1 and this R2. So, what number could I use to maintain the value? So let me explain myself. These two numbers are close to 5 because if I round off these numbers to just 2 digits, I have to transform this one to 5.0 and this one to 5.0. Why is that? Because as I've been explaining in the last videos, if I have a value here which is between 1 to 4, and the exercise or the professor tell me that I have to round off to the in this case to the 2 digits, to the 2 significant digits, then I have to maintain this number, so it is equal to 5.0. But if I have a value which is between 5 to 9, then I have to round off this number to the next one. So it would be a 0 and this transforms into a 5. So that is actually the answer. I just have to use 2 significant digits in order for the 2 numbers to be the same, actually. So that is the answer to 2 significant digits. The second one, to what number of significant digits can you express the area of the hole? So I just have to find the area of the hole using these numbers and see how can I express them in order for them to be the same number, like we did with this in this case. So as we already know, the area of a circle is equal to pi times the radius to the second power. So in this case, it is equal to pi times 5 to the second power. We're going to do this in the calculator. So pi times 5 to the second power. It is equal to 25 times pi, which is 78.5398. This is the actual area of the hole, but we have to evaluate it using these 2 numbers. So pi times 499 to the square to the second power is equal to pi times 4.99 to the 2 is equal to 78 times 200 2597. And the next one is 5.01 to the second power. Pi times 5 to the second power. It is equal to 78. $85, 42. And one last digit, 8. So, as we can notice, these numbers cannot be rounded using the digits after the comma, because I cannot round off this 8 to the next number because we have a 5 here. So if I round this 8, that would be a 9, equals to 78.9. And if I round this one, because I have a 2 right here, I have to keep these 2, so it is equal to 78.2. I cannot like have a round off of these two numbers, so the name gets to the same number, so the numbers can get to the same number. So what I have to do is to play with the whole quantity of the number. I can see that these numbers, the two of them, rounds off to the number 80. So the answer is that one. I can only use one significant number. To what number of significant digits can you express the area of the whole? To just one, which is A equals, which is area, equals to 80 millimeters squared. That is the answer.